we were just going around, and I told my significant other to slam on the brakes. I think I found something cool.
5 years ago today, this video was shared of SpaceX testing the HEX heat shield tiles that protect Starship as it re-enters the Earth's atmosphere. Now we've seen them launch on Starship 3 times with 1 re-entry attempt. Now, some of these tiles fall off during launch and re-entry, which means that if you search the beach in the days following, you might find a tile like my friend Nick, who has actually found quite a few and has an extensive collection. In this video, we'll learn more about where and how these tiles were found, what their material is, and how they compare to the Space Shuttle tiles. I wanted to hop on here to talk about a post that I made that has over 1.2 million impressions on X, and that is talking about these SpaceX heat tiles, those tiles that all of you guys have been messaging me about, asking if I'm selling them, asking if you can get one, when the fact of the matter is they weren't even my heat tiles. A friend found them, and a lot of people envy what you got.
So I think we got really lucky, honestly. We had a storm blow through right after the launch, so there wasn't many people out and about. So the storm and the high tides, if you don't have four-wheel drive, it keeps people most away from the back of the beach there.
So how many days, from when the launch happened, how soon did you search, and how many days did you go out there?
We were out 2 or 3 days in a row. And it was a couple days after the launch too. I'd have to check the date of the photo of it. And it was the day before you ended up coming out. And I think everything came in on that first tide after the storm. So I think we got lucky with everything blowing in. We found a lot of little bits, but only a handful of big tiles like that.
Oh, and wow. What was your search area? Was it, because you drove a lot, but I assume that was just back and forth and back and forth.
About 20 miles back and forth. So each trip, 20 miles.
A lot of people are asking me if I'm going to sell them. Well, they're not mine. You're obviously not going to sell them, right?
So I am not going to sell my big prized pieces here. But I have a friend that found some as well. He just enjoyed the launch, being here and stuff. It's not anything that's a huge interest of him. He had mentioned selling it as well, but he wants to check into all of the proper legalities of it. So we've got all of the data from where we collected them, all the different locations where they were found. And the tile from the first launch, and I submitted all my information. They never got back to me on it, so I hope they used my information. But I do know they've contacted other people for the data and didn't request the tiles back either.
Right.
Okay. And was there a concentration of where you found the tiles, or were they really distributed evenly?
Concentration point. When the tide goes in and out here, especially with the storm blowing in, the wind kind of throws them to one specific area because the island has 2 cuts on either side for ship channels. So there's like a low point where the wind comes in to an angle where they all mostly go.
How far away were because you got 2 full ones, or was it just the one?
There's I have to count again. I don't know exactly what my friend found, but I have 3 fully intact tiles and then a cracked one. So I've got 4 total full tiles, all different shapes too.
And how far apart would you say they were?
They were all at least a couple 100 feet apart from each other. Even small little bits. There was a couple small piles of them and stuff like that, but for the most part, they were all a good distance apart.
So was it was these on the beaches of Boca Chica or on South Padre Island?
South Padre itself.
Oh, South Padre. So that is okay.
So they must have fallen out in the Gulf and then blown it.
Yes. Yeah, absolutely. Now, how obvious was it? Was it just right there on the beach, or did you have to go in the seagrass or anything like that?
The big tiles were right up on the beach. They seem to float pretty well when they're staying intact like that. They don't take on too much water unless the tile's broken. They seemingly absorb a lot of water. It's lost more than 20 grams already.
Okay.
So I don't know if you guys can see this.
Yeah. Yep. There's the GPS for it.
Okay. So right there, basically on the beach. So pretty much where the high tide would have brought it up, because the
Exactly.
wind could have picked it up and also blown a little bit, but evidently they're probably just heavy enough that the wind didn't make it go really far into the seagrass or places where it would be, very difficult to discover. So,
Yeah, no,
so
it was
was it
amazing.
like you were really like sharp eyed looking for it, or you're driving around there and say, "Whoa,
So
look, I can see one. That's obvious."
I had a friend in town. We're building a safari park here. So I had a friend in town doing some small little electrical things and just helping me do some construction. And we were just going out and enjoying the beach. He came and he enjoyed the launch with us while he was here. He was like, "Oh, that's a perk. That's cool." He's like, "I forgot they do that down here."
Yeah.
Um, right.
Yeah.
And we were just going around and I told my significant other to slam on the brakes. I think I found something cool. And I'm familiar with them and stuff and just saw the shape of it and just instantly knew. It was white side up, so it was black side down. But many were
Oh,
black
okay.
too.
Yeah.
The sea foam, sticks, debris, and there's a lot of beach litter from general
Yeah.
beachgoers,
Yeah.
fishermen, commercial waste as well. So we picked up a little bit of that too.
I just want to make 2 points because during the first launch, Joe Tagmeyer found half of a full heat tile. SpaceX did reach out to him, and all they really wanted was the location. So a lot of people are asking, like, what's going on? Is that legal? I had someone say the FBI is going to come knocking on my door, which has not happened yet. But I think they just want to know the location. Oh, there's one.
Yep, see it on the left of the booster, the burners.
Yes.
Oh, I see something. Yeah, something dark there. Yeah.
That is it. That is it.
Maybe that's
Yeah.
number 9.
Yeah. If you
Ah,
can zoom in, yeah, and be able to tell,
yeah.
maybe you never know.
I think this is as zoomed as they can get. Number 9. Now, do you have the numbers of the other tiles?
Yes, I can go grab them real quick too.
Yeah, what are they? Yeah, go grab them, please.
Be right back.
Please. I have to say
It's
please.
it's, it's kind of weird that there's 18,000 of it that it would just be number 9.
Yeah.
I
So,
almost wonder if there's different shape tiles, and that's like this is the number 9 shape.
and number 9, Mambo number 9, that would be what, maybe near the bottom?
Well, I mean, so you think if you're going on up, that would be the lowest ring. Yeah,
Yeah,
that's
right.
yeah. So yeah, if the others, I would expect the others would have very, very high numbers, or it may absolutely have nothing to do with the actual count.
We're being asked how much does it weigh? It's what, 13 ounces or so?
It was 340 something grams. I'm not sure that conversion right now. So
Mhm.
Yeah, a little less than a pound. Okay.
That's a half one, but is there a number on that one?
not a handwritten number, just the X marks the spot and the serial number.
Mhm.
So what are those X's? Does anyone know?
I am not sure, but it almost looks like where you would place another X for whatever was the
Mm,
most by one.
Or
that's
is it
possible.
just
Yeah.
Elon? Is it Elon branding, formerly known
Yeah.
as Twitter X?
Yeah. Who knows? Okay, so that one you'll notice it's very narrow compared to the other. So that is a
Yeah.
different shape.
Yeah, and it's so thick. And what number is that?
There's no
Oh,
number.
no number. Okay. Well, there's the really nice serial number. Damn.
Yeah, there's
Yeah.
not a number on the front of this.
How many screenshots are being taken right now?
I want to try. I'm not great with computers, but I want to do a diagram of the Starship and find out where their individual placements were.
Oh, that's
Yeah.
an interesting shape.
Row 26 at least. We know that much. And this one's got a little
Oh.
tooth. Oh, wrong side. Dyslexia. Tooth bite in it.
So row 26, tile number 9. I mean, these would all be maybe near the bottom.
Unless they're counting from the top and going down, because I'm wondering about that shape, whether that's something that would be going near the flaps. So maybe
Yeah.
26 rows up, and then you start to get near the lower flaps.
It's very interesting. And
That's possible. Yeah.
you have so many. You need to like get a safe.
Yeah. That notch out there is rather interesting. I wouldn't expect it to be in the more open areas of the vehicle. You'd be expecting it's going to have to be somewhere around here where it's trying to fit in, maybe right along here or some other odd notched out surface here.
But this is not unusual for people to find fully intact heat tiles, chips of heat tiles. And so I wanted to dive a little bit deeper into this and bring in an expert so we can talk a little bit more about Starship's heat tiles. Remember, there's 18,000 of them on the Starship compared to maybe the shuttle space tiles. So let's bring in our guest, Scott Walter. And you've been talking about this a lot lately.
Mm-hmm. Yeah. As I was on a podcast with Royden D'Souza the other day with Dr. Ed Pope, who has actually worked on the shuttle program and the heat tiles and knows a lot about thermal management on spacecraft. And we had a kind of, a good discussion to understand what's going on with the heat tiles. Now, if we look behind you right now, I think that soundproofing you see the pink tiles behind you, those are hexagonal shaped tiles.
Yes.
They might be roughly about the same size of the actual heat tiles. Maybe the tiles are a little bit bigger, but they're hexagonal for a reason because they fit together. So obviously you can make them square, but if you make them circles, then they don't fit together so well. So they're hexagonal for a reason. And I think you may have a couple that you found. And for those who need to know is that whenever you re-enter the atmosphere, there's a lot of heat that you've got to worry about managing. Otherwise you will burn up. And whenever you see a meteorite or something like that, that's a rock that's coming through the atmosphere in many cases. Sometimes it might be ice, but in many cases, they will actually be metallic objects, and they get so hot that they burn up there. And they're coming in at roughly the same velocity because you have a lot of friction. And of course, a lot of us know we rub our hands together really quickly. We're able to generate heat in our hands. And if you do this through the air, you say, well, I'm not getting much from the air, but you're going through at hypersonic velocities, you're generating a lot of heat, you're generating the plasma you're seeing, and it's got to go somewhere. And what's going to happen is going to go in the spacecraft. So you got to do something to get rid of that heat.
Right.
And there's a couple of ways. The way it was done in the Apollo era and, Gemini and Mercury is they use what they call these ablative heat shields. And the whole idea is that they actually sacrifice themselves. They had a certain amount of insulation, but what they would do is when they get too hot, they would actually basically expose the next layer behind it. So they were allowing the heat to kind of be pulled away and pulled away. Problem with something that's ablative, almost by its name, it's like it's not reusable. You kind of, after a while, it's used up. Now, they are trying to work on some that you can maybe use a couple of times. I think like the Dragon capsule and stuff like that are doing the same sort of thing for their reentries. But everyone's always wanted to come up with like the perfect kind of thermal insulation that could be used again and again. And it doesn't have to be ablative. It doesn't melt or do anything like that. And that's what the shuttle program came up with. And that's what we can probably talk about right now. But I'll let you get a word in edgewise because, I just run on and on and on.
Yeah. Well, you also know a lot, which is why I reached out to you. But I just want to show, I took some B-roll or some videos of the portions of the heat tiles that my friend found. He says that he walked and drove about 200 miles up and down the coast 3 days in a row. So one of these fully intact tiles that he found was actually almost 3 days after the launch, which was very surprising to me. Luckily, he lives near the area, so he's able to do that. I think there were a lot more scavengers after the first one, but interesting as well, I weighed the tile and it's almost a pound. So that means you have, roughly 18,000 pounds on Starship of just the heat tiles. So
yes.
And it's not even. So that's quite interesting too. But let me show you this insulation. This was a thicker piece that he found. One of them is, quite thin and it has it dips in, but there is, and he said that this red stuff might've been the epoxy.
It could be. I think what they have is they also have like a felt layer underneath it. So there are some images showing how it's mounted on there. And you'll notice that looks like it's a half section. So it might've been between the different seams. So when we look at it, okay, so there we go. We got a pretty good example of what it looks like is that it seems that the hexagonal pattern doesn't go all the way up there, that every now and then you'll see that there are straight sections. And that's probably about where the seams are, where they weld everything together. And the attachment method is the issue, is like they work really well. If they stay on, the whole principle of these things is they are just absolutely great because they do not conduct heat very well at all. And they can also withstand a lot of heat. And they're a silica based kind of thing. So they're basically like glass. And of course, anyone knows one of the properties of glass is it's very brittle. It breaks very easy. So you can't make these in big sheets because they become so heavy, they break under their own weight. So you have to make them small enough that they don't break, but you like to make them big enough that you don't have to have too many of them on there. But at the same time, you can't make them too flat because remember, you're trying to cover a curved surface. So the trick is, how do you put them on? And you've got different thermal properties that the spacecraft is breathing. I mean, we see it breathe as it gets colder. And when that happens, it means you get expansion and contraction, everything on there. So you have to worry about the fact that you're going to get some relative motion between where the tile is and whatever the attachment surface is underneath. So the big question is, okay, do we do it with epoxy? Is that going to be one way? Do we glue it on? And is that going to work? Or do we use some kind of mechanical fasteners? And it seems like they've decided to go with this idea of mechanical fasteners. And it may be they're trying to do a couple of tricks here, that by epoxying it onto the felt, it will then be stuck on the felt. And maybe you do something to then get the felt to remain kind of attached on there. Because the one problem with these things is they are so brittle that even if you start drilling a hole in it, you can't get an even hole. It'll just start to shatter and fall apart into little pieces.
Right.
So it's the delicacy that's the problem. And these things are clearly shaking off. Now, when was the first tile found? Like within a day after launch?
So actually he's commenting right now. I sent him the link, so if he's able to hop on, he'll hop on. But he says that tile that I weighed has actually gotten lighter too. It must have been waterlogged a little bit as well. But he searched, I think, 3 days in a row.
All right. So, and I think, if I recall, you already showed a picture of it like the day after. I'm like, holy cow, they're already washing up. Yeah. And the fact that one was found so quickly within 1 day almost tells you there's got to be a lot out there. It wasn't like the only one that fell off.
There's the Big Daddy. That is a fully intact, like, what a find. I've had so many people message me, and in some ways I'm like, why would I send this for free? Even if it was mine, why would I send it for free?
Yeah.
Also, if you're a real space fan, you would never sell it. You would keep it. I would keep it if it was mine.
Yeah. Now it is amazing that, it's somewhat is, I think they do put some sort of covering on top of it. So underneath the substrate is this silica glass based stuff. And then they put a glazing on top of it that might actually give it a little bit of strength, because otherwise you would expect that thing would have shattered when it came down. Now it is very it is very light. So when it came down, it wasn't coming down a lot of velocity. It probably floated down and hit it. But do we see the others? We do have shattered pieces when they hit the surface. Right. So it seems that if it comes off intact, it's going to be okay. The other problem is the vibrations that are going on. Remember, you're going to have a lot of relative motion, and you're going to have these neighbors that are going to be bumping up against each other. They're either going to push you off, or in some cases may actually cause you to fracture or crack. And probably once you get that first fracturing, then the whole thing starts to break apart. And that's why you're seeing a lot of those smaller fragments that are coming up. But again, when it comes down to the chances of finding one, if there's only one fell off, the chances of it being found are like practically zero.
Right.
Especially within 1 day. But when you start finding a lot, it tells you, oh, there must be a larger number of them still already out there, or that have washed up in different places, because the currents go all over the place.
Well,
that's an indication they came off at launch.
I had no idea that there were 18,000 per ship. Like that. I mean, like, for some reason, I thought it'd be lower, way lower. Just shows you like the scale of the Starship, because I've seen it in person. I've looked at it from the ground, and I've felt, held a full heat tile, but there's still like this disconnect that there's 18 freaking thousand.
Yeah.
What?
A lot of its material comes from the fact that it's very light. Obviously the more mass, that's why it's very light, because the heavier an object has, the more ability it has to also kind of retain heat. So that's almost a rule of thumb. If it's literally more massive, it will retain more heat. If it's very light, it's going to also hold very little heat.
Is it just silicate?
Oh, I think it's a combination of other things. So there's going to be a bunch of things. One is that not only what its constituency, but how it's actually manufactured or put together. So there's a couple things.
Is this the same material as Space Shuttle?
Similar. It's not identical, but it's very, very similar. So it has the same kind of properties, in that you can heat it up and it won't, it won't transfer it in there. And it also is this very delicate and difficult to maintain attachment. And that was like the problem with the shuttle program, is that they would always fall off. So they would lose hundreds per launch. And fortunately, in most cases, they were not in an area that would compromise it, except we know in one case, and that was the return of Columbia. So there's some parts of the structure that could withstand it, or because only a little bit of heat flux is coming in a small area, the rest of it kind of is able to compensate and draw some of the heat out from that area so it doesn't melt too much. And the problem with the shuttle program is that every tile was unique. There was no two tiles that were the same. So you had thousands, I think maybe tens of thousands of different tiles that would take a while to make. So, and they didn't know. It's like, well, which ones are going to fall off on this one? And it's like,
Right.
okay, these are all, we have to go get those things. And it was a very delicate process to get in there and hold. So most people felt after the shuttle program, even though they managed it and they could get the whole thing to work, it was such a headache that they were just going, there must be a better way to be able to do this without, because the whole idea was quick turnaround. And I don't think the shuttle, it never came close to the promise of being like just a couple of weeks or almost a week. It could be that the design is right, but the process of putting them in, there's just something wrong, that they're either not going in the right orientation, or you think about it, you're really blind when you're putting it in there. You're just kind of like popping it in and you're hoping everything kind of meets in and goes right. And it could be that they are just not really snapping in all the way. So they need to come up with something which is literally foolproof and very easy to pop in place. That could be part of the problem, is that they believe they're affixed really well, but there's some flaw in the process of getting them attached.
And they're all by hand, right? They're all by hand.
I think they're putting them all up here. Now, the attachment points that are going in there of those fasteners, those pins, those are being done robotically. And we've seen the equipment that does that. That was in Tim Dodd's video from about, was it 3 years ago or more? And I did like a forensic analysis of that to figure out which robots they were using and how they were actually doing it. So they're putting those things on there. So those are affixed.
The Starship heat tiles are made of a silicate material, and 18,000 of them are manually attached to the Starship. So let's compare Starship tiles to the Space Shuttle tiles, which we know were used extensively. Imagine this. Each shuttle is like a giant jigsaw puzzle covered in more than 24,000 6-inch square tiles. And here's where it gets sciencey. Most of these tiles are crafted from silica fibers. Think of it as super fancy sand. Silica is a champ at insulation because it's not in a rush to pass heat along. So when the tile's outer layer gets toasty, it's a slow journey for the heat to travel through the tile to the shuttle's exterior. Thanks to this, the shuttle's aluminum skin stays cool under 350 degrees. Making these tiles is a bit like baking a very complicated cake. You mix silica fibers with water and some chemicals, pour the concoction into molds, and then zap. Microwave them at a sizzling 2,350 degrees to bind everything together. But here's a twist. These tiles are super delicate. Directly sticking them to the shuttle would be a no-go because the shuttle skin likes to play it cool, contracting in orbit, then getting all expansive during re-entry. Plus, the whole shake, rattle, and roll from launching and coming back could wreak havoc on them. So the solution, glue the tiles onto these soft felt-like pads, which then get glued to the orbiter. It's like a cushion for the cushion. Now onto the finishing touches. The tiles that face the fiery heat of re-entry, especially on the belly, get a coat of black glass. Now this isn't just any black coat. It reflects about 90% of the heat back into space, while the inside of the tile absorbs and then leisurely releases at rest. This means even after the shuttle lands, those tiles take hours to chill out. For the parts of the shuttle that aren't subjected to such intense heat, the tiles get a different spa treatment, a whitewash made of silica compounds and aluminum oxide. These tiles are like the cool kids on the block, handling temperatures up to 1,200 degrees. Before every mission, the team ended up swapping out 30 to 100 tiles. When it's time for a fresh tile, it's over to Kennedy Space Center in Florida where the magic happens. They've got this computerized whiz that carves out a perfect fit using either pre-existing designs or fresh measurements from the shuttle. The thickness varies from a slim 1/2 inch to a bulky 4 inches, all depending on the need for heat resistance. And since no two tiles are cookie cutter identical, each one is specifically made. But let's get back to Starship. In March of 2019, Elon shared these tiles can withstand temperatures of 650 Kelvin, a whopping 2,510 degrees Fahrenheit. The hexagon is a great shape because it offers no straight path for hot gas to accelerate through gaps. If tests show any heat shield erosion for Starship, SpaceX plans to add additional cooling systems to protect the spacecraft. Elon was once quoted saying, "Transpiration cooling will be added wherever we see the erosion of the shield." Starship needs to be ready to fly again immediately after landing, zero refurbishment. While the hex tiles will protect Starship during re-entry, don't expect the polygonal heat shield on the Super Heavy booster. It's made of stainless steel. Elon said Super Heavy booster is stainless steel since it only goes to around Mach 8 or Mach 9. Moreover, at high altitude, it needs no heat shield, not even paint. If you guys have made it this far in the video, congratulations. You clearly are interested in this topic. So I'm just going to read a synopsis by Dr. Walter, who you saw earlier in this video. He wrote, "It's not the heat tiles, it's the fasteners." After our live stream, he said that we learned a lot from examining the half dozen intact tiles that Nick was able to retrieve. Too long didn't read. The attachment process is likely flawed in his opinion and not the tiles themselves, and here's why he thinks that is. Nick recovered many fully intact tiles on the beach within days of the launch. He also found some shattered tiles, but those tiles had been run over by cars or trodden by horses on the beach. So it's not clear whether the tiles broke apart on the orbiter during launch or later after impacting the water or when washed ashore. Each tile is affixed to the orbiter with 3 fastener pins. These pins are welded to the orbiter skin and not likely easy to break off. The suspicion has always been that where the pins affixed to the tiles is the weak point. When under load, either the tiles fracture or the anchors rip out as if in drywall, but that does not seem to be the case. The image on the back of the intact tile shows the anchors neatly in place with no signs of damage. Because the tiles were discovered so soon and so close to the launch site, they were likely shook loose from the vibrations of the launch or soon after from aerodynamic loading. If they were fragile, then they should have shattered or the anchors torn loose. Apparently they did not. Even after impacting the water, yes, they are light, so likely floated down at low velocity and being roiled in the surf. If the fastener pins dislodge from the skin, then one would expect to see them still attached to the tiles. They are not. Plus, if loading is enough to rip the pin welds off the orbiter, the tiles should have shown damage or the anchors failed ahead of that. Only intensive vibrations could account for that possibility, not aerodynamic loads. Most likely where the fasteners clip onto the tiles is unclipping. Why is a mystery. We all know a clip fastener is nearly impossible to remove and special tools and tricks are needed to unclip. And that's if a clip is even designed to unclip. These clips are likely designed to be one way. They go on, but you can't unclip them. So could there be some strange vibrational mode that allows the clips to dislodge? Maybe. We know bolts untighten when under vibration, and it is the reason for Loctite. Still, this usually requires a lot of time. To happen seconds or minutes after launch is indicative of an unknown failure mode, or the clip heads of the fasteners are failing or snapping off. The other likelihood is the tiles were not properly snapped on. With 18,000 tiles packed tightly together, it may be difficult to verify proper installation of every tile. It could just be a quality assurance issue. It's really hard to see back there. Another remote possibility, Scott wonders, is that stacking, destacking, tanking, and detanking and thermal expansion are culprits that start to wiggle the tiles loose prior to launch. Given the multiple attachment points, all the pins would need to cooperate in the process. If one is stubborn, it should require the tile to fail rather than simply slip its bonds. Unfortunately, we do not yet know how the tiles will perform under the stress of re-entry. He's confident that from thermal management, they will do fine. But they can't do fine if they don't remain attached. We need to see if they are too fragile to survive re-entry loading, but if they can, then the problem may only be the fastener design. If so, these tiles remain a viable solution in the near term for Starship until better alternatives are explored. Which was a very thorough explanation, and I really appreciate him writing that. It's a good synopsis summary of what exactly is going on or what he thinks is going on. So if you made it to the end of the video, hooray! Thank you so much for watching the full video. I hope that you enjoyed it. If you do, please make sure to subscribe to Ellie in Space. Give this video a thumbs up. And consider ordering a t-shirt to celebrate the 3rd test flight of Starship. Here's that design. Whether or not you were there for the first flight of Starship, you can have this commemorative IFT1 design. We have these shirts and hoodies back in my store up and running. And better yet, we also have a design for IFT3. Ordering merchandise is one of the best ways to support my channel, plus you get something out of it. I saw a lot of you guys last time I was at Starbase wearing my design, which is truly an honor. On this IFT3 design, we focus on Ship 28 and Booster 10 and the re-entry with the beautiful plasma field views that we saw powered by Starlink. So if you guys want to add either of these to your collection, the deadline is Friday, April 5th.